Given an array of strings words and a max width, format the text such that each line has exactly max width characters and is fully left and right justified. You should pack your words in a greedy approach. That is, pack as many words as you can in each line. Pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on a line does not divide evenly between words, the empty slots on the left will be assigned more spaces on the slots on the right. For the last line of text, it should be left justified, and no extra space is inserted between words. And note that a word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not exceed max width, and the input array words contains at least one word. So let's go over a few examples now. So we have the words. This is an example of text justification, and our output are the same words but just formatted in a series of lines. And it looks here that our first job is to partition the words into lines. First line, second line, third line. So job one, partition words into lines. Job two, now that we know from this index to that index, this is corresponds to one line. Next few words, example of text, corresponds to the second line, and justification corresponds to the third line. How do we actually format the line? So format lines, including the spaces, etc. So the first job perhaps may be slightly less complicated than the second. So first, we can just try growing a line. We initially have the line equal to this, and its length is equal to 4. And we just try to add on spaces and words until we exceed max width. So since we have to have a space in each word, between each word, and the minimum number of spaces is 1, we take the greedy approach and just use the minimum number of spaces and try to add on the next word, which is, and we find the length increases to 7, which is still less than max width, which is okay. Then we try to add on un, and we increase the length to 10. That's okay still. Then we try to add on example, and we increase the length to 18, which is above max width. So we cannot use this. We must use it on the next line. So now we know that the first 3 words are on the first line. So next, and we continue it for example in place of this, and for the second line, the same process to create the line. So this is the first part of the logic, our plan to attack this problem. The second is actually given the line, this is or any line like such as example of text, max width equals 16, we need to properly formatted string that represents the line, including the spaces. So here, this is perhaps the more complicated section of solving this problem, but we can refer back to the problem statement for this one. So let's define a few variables. Since max width, since max width is 16, there must be the width is the contributions to the width are the space width plus the word width should be equal to max width. And the word width is the sum of the non-space characters in the lines, such as here there would be 8. So space width should be 8 as well to add up to 16. So we have 3 words. 3 words. We would, this is something called a transpose problem, I guess. Transpose issue is sort of related to a minor. It's sort of related to off by 1 errors, but if you have 3 words, there will be two space, two, white space areas between the words. So to find out how much white space we should have between each word, we should divide space width by number of spaces, which is the length of the line. How many words are in the line? Number of words in line minus 1. And the problem is that it might not be evenly divisible. So we would have extra spaces would be the remainder of this divided by number of words. We just do number of spaces. And if you recall the problem statement is if there isn't an even number, if we have extra spaces, we would need to add the extra spaces to the earlier, the lefter, that's not a word, but the spaces that are the white space areas that are on the left. So we have the line. This is let's build the string. This. So we start with we have an equal. Let's say we have an equal white space in between each word, which is just an empty white space. This is Python. This is sort of Python notation, but just the space character repeated n number of times. So here we would have the word count is the space width is 8. Number of spaces is equal to 2. So here it divides evenly. So we should just have 4 characters in between it. So our final result equals this plus space plus space, white space area. And now for the second line, we just finished the first line. Let's add a small divider here. And our result, let's define it up front and later gather the proper ingredients. So the result should be, since we know the line is example of text, the result should be some formatting of those characters, some arrangements, those, and some number of spaces. And these spaces, they might not be equal because the it might not evenly divide. So we'll see. So we find that the word we remember that recall that max width, the width of the line should be equal to the width of the spaces plus the width of the words. And here the width of the words is 7 plus 6 equals 13, and so the space width should be 3. But notice that we have 3 words. Number of spaces is 3 words minus 1 is 2, and 3 is not evenly divisible by 2, so we must have SP1 and SP2 must be of different widths. So we start with a baseline width of 3, which is the number of space width divided by number of spaces. This does not consider the remainder, so this is times 1, since 3 divided by 2 is equal to 1.5. Integer division gets rid of the decimal part, and we end up with 1, so it's just 1 space. And the remainder space, extra spaces, equals space width, which is 3 divided by number of spaces, equals 2, which is equal to 1. So we must distribute these extra spaces among each space. So we start with example. We start with the baseline number of spaces. We check if there is any extra space. There is. We consume that extra space, so it becomes 0. Then we add the baseline spaces 1. We check extra spaces is 0. We don't need to add any extra spaces. And the result is example of text. So the last line, we have different rule for formatting from the other lines. So let's say we had another word here. Let's say we had another word here. If there were more words afterwards, like an extremely long word, we would have something like this. But since it's the last line, we should just have 1 space between each word and have everything right padded as per the problem statement. So now let's start coding. I think it may be helpful to implement certain methods after we invoke them. So let's just do a high level sketch right now. So obviously we would need a vector to hold the result, the lines. For line, we would need to push back line, and the end we'll return lines, and we want to decide how we want to go about with the partition. So each iteration of this loop should correspond to one partition, and since they're contiguous, we can have two indices that represent the first word in the partition, the last word in the partition, and at the end of the loop, we would update the partition. So L would be on +1, 2 for the start of the next line, you know. So while L is less than words size, we do the needful. We find, well, we first would need to generate the partition. We would need to find the proper index. R would be, let's just call it find right. Pass the appropriate parameters, words, text width. Now we do have the partition. Now we would just need to format things. So string line is equal to format LR. These represent our partition, words, and max width. And I think that's all for the top level functionality. This is the first step I mentioned. This is the second step I mentioned. So let's implement find right now. Find right. Int L string vector of string words and max width. And let's think about how we want to implement this. We don't actually need to build any, we don't have to manipulate any strings here. We can just deal with the lengths. So we can have the initial length to be well, we know that at the very least the word at L will be included. The word at L will be included, like the partition might just have one word. So would be words L.size. And we also want to have an index that we iterate using L+1. And while idx is less than words.size, okay. And so size is the line width so far, +1 for a space. When we're adding a new word, we need to add a space, plus words.idx.size less than max width, less than or equal to max width. We would want to add the word at idx to the partition. So size, we would want to increment size by plus words idx size, and we can't forget to increment idx itself. We can just do a postscript increment here. That's okay. And the result is, it's not idx actually, because idx, number one, it might end up on words that size, and as I said, it's inclusive, and when this condition fails, there are already enough words in the line, so the last word that was added, idx -1, is actually the inclusive right endpoint, so you would want to return this instead of idx. And this is the first part. second, more challenging part is actually formatting the line. Format R string vector string words int max width. And one case we would need to consider if there is just one single word, i.e. if L is equal to R, we would just want to return that word itself. Perhaps if it's like justification here, it's a long word, but it's not longer than max width. We would want to pad some spaces on the right, so we could define a function that does just that. Give them a string word and then int max width. We would just want to pad some number of spaces on the right to make the word's length equal to max width. And let's be lazy and just implement that later. Return pad right words dot L, R would work too. Max width. Now comes the more challenging parts. So for each word in the partition, we would want, we need to start with a line, obviously, an empty string. We would want to append the word to the line, we would want to append some number of spaces. Let's just call it set for now. Sep would be, as I said before, in this language we have a constructor. So string, let's say 3 and A. This would just get a string, this string. So we need some number of spaces, which should be, it should be, as we recall, space width plus word width is equal to max width, should be equal to max width. So we would have space width divided by number of spaces. Number of spaces equals to, there are R minus L plus 1. We can't forget about the first element. But since they're in n words, like 3 words, there are 2 spaces, so we just minus subtract 1. And so there are R minus L spaces. Space. And we also need a variable to keep track of any extra spaces we need to distribute. Remainder is equal to, the remainder from this division here. And we actually would need to use this remainder variable. So if remainder is greater than 0, we would want to append an extra space. Otherwise, just an empty space. And we can't forget we need to change the variable itself. So we post decrement it, and that should work. At the end, we return line. And this, we also need to get these variables here. Space width, we actually need to calculate that or somehow pass it in, but we can wait until later. String space, number space, num space. And also, yes, if it's the last line, like recall that right padded plus single space between each word plus right padded. So for here, we can actually change the parameters sep and use the same code here. It looks like, at least, so we can add an indicator. Those last and last, how would we know if it's the last? Well, if the partition LR is contiguous, so R would be at the final words, the index of the final word. So here is the flag, and we would just want a single space here. And we would not want to distribute any extra spaces, so add 0. That looks to me, and also here we unless it's right padding, we don't want to append any extra spaces, for the last word in the partition. So we just exclude R and add the words separately. And we actually need to go back and implement finding the word width. Since we're actually iterating through the words here, we can somehow get the data from this function instead of iterating through the words again. And I think it may be cleaner just to have it here, but I don't. A bad habit of mine is making things more complicated than they need to be, so I'll obtain it from find right. I guess, to save an iteration through the words. And let's check the constraints. It's usually a good idea to check the constraints. The words are not too long, so it really doesn't matter here, but let's just get the word. Let's just somehow find a way to pass the word length from this function to here. We start by word width, by adding a parameter word width, and space width equals max width minus word width. And here equals, we would want to return word width. At z, because the first word is, the line starts out as the first word. And here, let's have a variable w that represents a word width, size. Let's keep the increments in. Size 1 plus w, and word width plus equals w. And we can actually return a tuple, instead of some sort of custom object. So we need to make tuple width, and here we would need to pass in. So also forgot to declare the variables. And let's say word width. And to, I guess, unpack the variables, we would use something called tie. And here the order is the index r and word width. Now we can pass it in. Also, we need to implement pad right, but before that, if the line, I assume the line might also need extra padding at the end, even if there are words in it, such as this one, acknowledgement. We have extra spaces at the end. We need to pad right here, so line max width, and this is relatively simple, so we would do word plus some number of spaces, so max width minus word dot size, length, I think both are okay. This should pad it to max width. Word length plus max width minus word length is equals to max width. So let's try running the code. Hope that everything goes well. It looks like it was sort of slow, so okay, let's try to submit. It looks like it's a okay solution. So thank you for watching this horrible first video, and I hope this helps you in some way or manner to get a better job. Okay. Thank you, and have a great night.